되더라. 이쪽으로 가세요.
What if the climate cooled, tensions thawed, and the sky was a clear blue? What if power outages were a thing of the past, and our businesses were future ready? What if our digital footprints were no more dangerous than our physical ones, and the only limits to a better world were the limits of our own imagination? What if this weren't just a pipe dream, but a possibility, even a promise? Because while prosperity is an ambition, not a guarantee, progress awaits, and technology is the most powerful tool humanity has. With technology, we can build a digital blueprint for a better world, where AI-enabled smart grids accelerate the energy transition, and the products we buy exceed our increasing expectations. Where electrifying transportation is not only sustainable, but also efficient, consistent, resilient. Where buildings self-optimize. Healthcare is personalized. And the next big idea is just one leap away. This is what's possible when data combines with advanced technologies to reveal industrial insights. And those insights enable us to decarbonize our communities. It's the promise of software-defined machines that adapt to ever-changing conditions and give us ever better goods. Robots that pick and pack with human-like precision. And co-pilots who understand and advise. So humans are free to do the work that only humans can do. It's the power of industrial AI, fundamentally transforming the way we commute, consume, create, play, work. It is the impact of Siemens, our ecosystem of partners, our customers, together using the best of digital innovation to create a better real world, today and for every day that follows. This is technology to transform the everyday for everyone.
Please welcome to the stage, Peter Kurta.
Well, good afternoon. It's great to be here at CES with you this year. Last year, we were at CES to talk about the industrial metaverse, about the 3 building blocks, what it takes to build it. We talked about physics-based digital twins, software-defined automation, and we spoke about AI. Now this year, we are here because we know that on everybody's mind is AI overhyped? And we'll show you today that the answer to that very question is absolutely not. Why? Because AI is going to create real impact across all the industries that we at Siemens serve today. We have a lot of news to share with you in the next 40 minutes. So we're going to start and talk about announcing 5 new AI-powered products that will help our customers to solve real-world problems. We're going to talk about a very exciting partnership with JetZero to completely reimagine air travel. And we're going to talk about collaborations with our ecosystem partners to scale our impact. So incremental change, iterative innovation is a natural human inclination. But in the face of an environmental crisis, of geopolitical instability and shortage of skilled labor, we don't need steps, we need leaps. And at Siemens, we are giving our customers the confidence to take those leaps by fundamentally transforming the way how industry operates. And the way we're going to do that is through industrial AI. So, what is so special about industrial AI? Well, If your regular AI gets the tone of your email wrong, that's one thing. But think about it. If the AI gets the programming of a machine wrong, or a medical diagnosis wrong, or even the management of an energy grid wrong, the consequences can be outright catastrophic. So therefore, industrial AI needs to be safe, it needs to be reliable, and it needs to be trustworthy. And as you all know, AI needs data, a lot of data. And it turns out, as you probably have read, that for training these large language models, we are about to run out of data to train them. But in the industrial world, it's a very different thing. Not sure if you know, but there are 17 billion smart devices out there, twice the population we have on this planet. And that number is going to grow by almost 20% every year. And these devices, they're going to generate an enormous amount of data, a rapidly increasing amount of data about the products we use and about the world that we live in. This is a huge data treasure. Except 80% today is not used. It's valuable data wasted. But with industrial AI, we can turn this data into impact and we can turn it into real value. That's why we are absolutely convinced that industrial AI is going to be the game changer going forward. In fact, today, already we have more than 30 AI-powered applications with real-world impact. And let me give you a few examples. Take buildings. As you all know, we spend 90% of our time in buildings. And with this industrial AI, we're making these buildings more efficient, we make them more comfortable, and we make them better for the planet. But how? Well, as just one example, we take our AI-powered offerings to manage cooling systems, and thereby we reduce energy use and carbon emissions by 30%. Or take energy grids. You probably know that the demand for electricity is expected to double in the coming years, while the share, at the same time, of variable renewable energy sources like wind and solar is rising too. And for grid operators, that means a significant challenge. But with industrial AI, we can help them to increase grid capacity by 30% and manage that fluctuating nature of those energy sources. Without AI, this energy transition could not happen. And then lastly, take factories. And there's a lot of talk about factories because there's an enormous amount of shortage of skilled labor. The people with the expertise to program or maintain the machines on the shop floor, they are leaving the workforce. Since 2019, the average factory worker's level of experience has dropped from 20 years down to 3 years. 3 years. And American manufacturing executives, they have unsurprisingly seen a corresponding downturn in output. Industrial productivity, down 10%. Product recalls, up 33%. And workplace fatalities, up 9%. So, imagine, you are a new employee, and it's your second week. You're working the graveyard shift on a Sunday morning in a factory. And suddenly, the machine in front of you, it breaks down, and the line stands still. You look around, there's no colleague to call, and there's no manager to address. That is exactly the perfect place where industrial AI technology can help. So specifically, Siemens has developed together with Microsoft the Siemens Industrial Copilot. The Siemens Industrial Copilot functions pretty much like a human colleague. It's a smart, experienced human colleague, except it's available 24/7. And it helps you set up your machine, to program it, and to troubleshoot. Already, more than 100 companies are using the Siemens Industrial Copilot, which is the first Gen AI-powered assistant designed specifically for an industrial environment, because it is safe, reliable, and it is trustworthy. So it enables workers to make these better decisions, smarter decisions. And we want to scale this technology because we want to ensure that all customers can have access to the Industrial Copilot wherever they want to have it. Today, they can run it, the Siemens Industrial Copilot, in the cloud. This is where we started. But we know that many industrial companies don't want to have their sensitive data to leave the safety of their factory. So we made the Copilot available on-premise too. And now I'm very pleased to share our first product announcement of the day. That is, we are bringing the Industrial Copilot down to the industrial edge. So by bringing it to that shop floor, it means that the device sits right beside our customer machines. And with the Copilot on the edge, the data processed right there on the factory floor. And thanks to our partnership with NVIDIA, we bring high-performance compute with GPUs down to the shop floor. And that means that our customer-sensitive data is always secure, latency is much, much lower, and the costs are lower too. So, these are just a very few examples of the many we could show and share with you today of how we are using industrial AI to make real-world impact. So yes, AI is a lot more than just hype. And you get even greater value if you combine industrial AI with other technologies, such as digital twins. And therefore, I want to bring out one of our customers who is doing exactly that. So please, everyone, welcome the co-founder and the CEO of JetZero, Tom O'Leary. Hey, Tom.
How are you, Peter?
I'm great. How do you feel?
Fantastic. So happy to be here.
We are too, because I have to say, we talked about, we want to take leaps and not steps. And that's exactly what you're doing actually at JetZero. You're fundamentally changing the way we think about air travel. So that's why we're very thrilled to have you here. And maybe you can tell us a little bit about this airplane that we see in the back, because I'm not sure about you, but the airplane I came looks very different to the one that we're looking here.
Yeah, absolutely. So happy to share this with you. Really, when you look at this airplane, the shape is the new technology. It's brand new from tip to tail, though. From the avionics to the engines, we're using really existing systems, and that's so we can speed its entry into market. Because really, why we want to bring this to the market is the shape allows us to address everything that the market demands, what our customers demand at the airlines, right? And that is, with a blended wing, you can have an incredible step change, a jump in efficiency. That's what our airlines need most. They know that this shape allows us to change everything for the better, whether it be better performance, better comfort, and they need us to do that seamlessly within the infrastructure and the environment that they operate planes in today. So this plane is just what the doctor ordered.
Looks terrific. Now, I would think that to build something like this, you're about to build it,
yeah.
You need a lot of technology, cutting-edge technology, and you choose Siemens as your technology partner. So share a bit with us why that is.
Yeah, this is an incredible challenge. It's an incredibly big and bold challenge to bring a new commercial plane to market, right? So we needed the best, and of course we wanted to partner. We have to build this new shape at high rate, because the demand's going to be high. And so we wanted to partner with the global leader in manufacturing technology. But it goes so much further than that, right? Because it's about the technology, the design, and also the technology to make those designs real from the twin into manufacturing for automation. So Siemens offers us the power of a fully integrated platform. It can't be understated how important that is for a company like JetZero to realize this full vision. So we need to gain insights. We need to look at full-scale production before we ever put a shovel into the ground and build that first factory. So together we're going to create a roadmap that's going to lead us from engineering design all the way to full-rate production.
Which is exactly the challenge we always look at as a technology company, and that's why we are very glad to announce today that JetZero and Siemens, we're coming together and we've signed an agreement on the technology that will revolutionize the future of air travel.
Absolutely.
So we're very happy about that, and maybe we talk about that very future because your blended wing aircraft is due to debut already by 2030. So that sounds rather ambitious.
Yeah, 2030 is right around the corner, really, from developing a manufacturing and so forth. It's coming soon. So the only way for us to get there and collapse the time frame is with industrial AI. I mean, this is so critical. It's going to help us get there. And ultimately, we're engineering a product for our customers, the airlines, and that will improve their performance. Industrial AI is going to do the same for us. That's what we as customers to Siemens look for. So Siemens is already providing us all the fundamentals that we use today for design, tools, digital twin, digital thread, all the way through to building a factory of the future. It is the backbone for us. But our vision is that Siemens will be a partner to show us how AI is going to inform and really even just accelerate everything that we're doing from the design all the way through to the manufacturing.
What we like a lot about what you're doing is that you want to create the world's first aircraft that is fully digital, meaning from digital design to digital production to digital maintenance. And maybe you can talk us through about also starting this design, what that really means for you.
This is a great big challenge, right? Because we're entering a very mature space, right? So this digital twin is a strategic competitive advantage for us to be able to begin with the end in mind and effectively create a simulation virtually. We can de-risk the manufacturing process, what you showed there, and we'll see more. It's going to let us validate our approach and scale our processes long before we take these planes to the skies and before we break ground on a factory. This is an incredible, it's basically a leap forward right off the starting block when you're building something from scratch. So thrilled about it.
So you spoke about that very digital twin, and we have to think about that. You actually can also immerse yourself in there so that you can start to design, collaborate, explore that product with many people around the globe.
Yeah, this is so important for us as a distributed company. We started the company in COVID. We had no facilities. Everybody was distributed globally. So this is so critical to what we do.
So then, last year at CES, we showed a groundbreaking new product that can enable exactly this kind of immersiveness, which is the Sony head-mounted display for immersive engineering. And the great news also today is that very device, like pre-showed last year, it's now available for purchase. And this mixed reality headset, it enables the next generation of 3D content creation. It's built on a Qualcomm Snapdragon XR2 Gen 2 platform, which gives us the compute that we need to make it seamless. It has two 1.3-inch OLED microdisplays with 4K resolution, which means it pretty much matches the precision of the human eye. And with the two precise finger controllers, it's very intuitively to manipulate and to design these 3D models. There's 4 tracking sensors to track the spatial information, and the haptics are amazing because they really feel incredibly natural in that very mixed reality experience. And I only can invite you to test it because the headsets are very comfortable that you can wear them also for extended use. And these headsets were originally developed by Sony for their own engineers. Engineers who used our Siemens software at the time, and still do, to design the Sony products. But the Sony folks they got so excited about that they found the immersive experience so beneficial, they partnered with us. So that we also can offer it to our customers. So customers now like JetZero, and Tom, therefore the question is, how would you envision to use such a device as the Sony advantage?
We just can't wait to get our hands on it and utilize it for effectively everything. I mean, that's really the plan for us. So maintenance, manufacturing, inspections, and we want to accelerate that. On the way here, I stayed on the tarmac for an extra 2 hours because they had to make a small minor repair, and then it was really the paperwork that we were waiting for. So we're looking for a world of maintenance where these type of devices can be huge. But really, productivity improves in the design process when engineers can engage at human scale and collaborate globally. So where colleagues can access the information and the designs from anywhere in the world and collaborate from any of the world, the speed and insight that this provides us, it's going to have an extraordinary influence on how we design the airplane and how we mature the whole design process.
That's great. So that's all about the design process, but we also talk about the factory. So how are we going to build that? So I understand that landed wing aircraft will be built at a factory right here in the United States. Any news to share where that is, that factory?
We can't share that just yet, but we have been going through a rigorous process. It's going to be here in the United States. The Air Force is one of our customers. That was something that they were particularly keen on, is making sure that we were building our factory here in the United States. But it's going to be a fantastic state-of-the-art facility that we're relying heavily on Siemens expertise to help us build.
Great.
End of the first quarter.
In the first quarter? All right.
Within the first quarter, we'll announce the state where we're putting the factory.
Now for us, that very factory is very exciting because we also want to bring our customers there to show them how hardware and software is really working together and can create additional value. So tell us a bit about that factory, Tom, if you would.
Well, I mean, really, the impact for the environment for this plane is going to be significant. But what we'll be able to do is use automation and digital tools to adapt quickly to the changing demands. I mean, this is going to be a next-gen factory. So interconnectivity to the production line is key. Really, we're just looking forward to being so much more agile because of the software and the hardware that are tied together. This kind of, digitally native design through to manufacturing that we're doing is just simply not available through legacy systems. It's a step forward. So that's a great advantage that we look forward to being the beneficiaries of.
That's great. And exactly that's what we want to do. So we want to bring many of our customers there so that they can see and that believe really what is actually possible to bring all of this together. And since you've been at Tesla, you know pretty well of how important that is to scale up and already think about in the very early design process about the design for manufacturing.
Absolutely. We're just, lather, rinse, repeat. We're deploying those same sorts of principles as we work on JetZero.
That's great. So may I shift gears to sustainability? So JetZero obviously is all about zero, I would imagine, on carbon. We know that aviation is a contributor to greenhouse gas emissions. And the landed wing aircraft actually has, I guess, a lot of advantages to get us there.
Yeah, this is a much more pragmatic approach to how we get to zero carbon emissions or net zero, which our name implies, right? That's the ultimate goal. We feel that goal is inevitable. It's a matter of, what kind of time horizon. The question is, what's the first move forward, right? And so we can get to a 50% improvement by lowering fuel burn by 50% with this design. And then that's going to enable us to move to more sustainable fuels, but really all those solutions that get us all the way to net zero and then absolute zero, those all come at a premium. So the first thing you do is lower that burden. So this design is really the first way to do that.
That's fantastic. So, we are convinced this is the right way of going. So we have a clear vision of where the shape of air travel is going to go. And we have a clear vision of where that technology is needed where that is going to go. And together, obviously, we can realize that very vision.
Agreed. We're so happy to be partnered with Siemens on this. Again, for us, it's so important to be partnered with the global leader in manufacturing technology, and we're just grateful for your time and interest in helping us do what we need to do to achieve our vision.
Thank you, Tom. For us at Siemens, it really is a big pleasure. It's very exciting to revolutionize the way we all travel on these aircrafts every day, and it's been exciting and a privilege to have you here.
All right, thank you.
Thank you. Now, you just heard about how Jet Zero is going to use Siemens technologies to transform air travel. And these technologies are available on Siemens Accelerator, which is our open digital business platform. And in many ways, the world runs on Siemens Accelerator, because every car maker, including all the leading global EV manufacturers, they use it. All the top 12 global aerospace and defense companies use Siemens Accelerator, and as do 100% of uncrewed spaceflight. 8 of the top 10 consumer companies and 8 of the top 10 battery suppliers are Siemens customers. And as a matter of fact, when you leave here, you might hear from Samsung, or you may go to Panasonic's keynote. So what happens? These are Siemens customers. In fact, every single company that is delivering a CES keynote here is either our customer or our partner. And that's why we love that the biggest companies are actually using Siemens Accelerator to achieve their goals. But what about the smaller ones? And this is where we also have news to share, because like with Jet Zero, we want to bring that also to startups. Today we launch our Siemens for Startups program, because we want our technologies, our expertise, and our ecosystem to be accessible to companies of every size. Through this program, early stage startups, they get access to essential Siemens offerings and Accelerator at a significantly reduced price. So 90% off the first year, 80% the second, and 70% in the third, and occasionally even more. And our partner, AWS, they will also give program participants another $5,000 in AWS credit for cloud computing. So with that, everything about the Siemens Startup program is designed to help the startups scale. And startups like the ones you are able to see at our booth. And there you're going to find companies like ArcBoats. They are out there to electrify the marine industry. Or Spinover, which is a Finnish startup that turns wood pulp and waste into sustainable textiles. Bayer Water, which lowers the cost and carbon footprint of clean water. And Desert Control, good stuff, which is making arid land fertile. So founders, they can apply there for the Siemens for Startup program right now, and you can learn more about it if you go over to our booth in Eureka Park. So the world's biggest companies, they are using Siemens technologies, and now the world's smallest companies are also going to use our technologies. And just recently, the NVIDIA CEO, Jensen Huang, he said, well, Siemens actually has become the operating system for industry. And to tell you more about how we are enabling our customer success and to share some more very exciting announcements, I'm very pleased to welcome my colleague, Tony Hemmelgarn.
Thanks, Peter. So Peter referenced this operating system for the industry. I'm excited to be here today because I get to talk to you about how we're strengthening and expanding the technologies that are part of Siemens Accelerator. So we're not just throwing a bunch of tech together. We're doing this to help build out this physics-based digital twin that Peter referenced. And over the next few minutes, hopefully I can better explain what we mean by this physics-based digital twin and what it really means for our customers. It's very valuable to be able to link that digital world to the real world. And the closer you can make that relationship, the more valuable it is for our customers. Because they need factories that can respond to really real-time conditions. They want processes that can self-optimize in the moment. They need answers to very, very complex questions. And some argue that the way to deal with all this complexity is to reduce the complexity. That's not realistic. Products are becoming more complex, the manufacturing processes for them are more complex, as you just heard, and what's going on with some of the technology that's available today. So we think differently. We think we can have our customers use complexity as a competitive advantage. Use complexity as a competitive advantage. What do we mean by that? If you've got all this complexity, you need to be able to make decisions very quickly and with confidence. If you get enough digital representation, that real linkage to the digital, if you can get that close enough, you can move really, really quick and go through that complexity. You know, we just heard about Jet Zero talking about what they're doing in aviation, and it makes me think about the Wright brothers. Theirs was not a step, it was a leap of faith. Can you imagine you're standing on the edge of that hill, and you're about to do that first flight? Is this aircraft going to hold together structurally? Is the engine going to keep running? What if it's a windy day? What's that wind going to do to the effects of the airflow across the wings of that plane? I wonder the Wright brothers, what their experience would have been if they could have used some of the technology we're talking about today. So today, for example, we're introducing a new Copilot specifically for designers. This is one of many Copilots that we're doing with Microsoft. Microsoft brings the platform, we bring the industrial data. It's a very powerful combination to be able to bring those worlds together. We gather critical customer knowledge. As Peter referenced, we keep it private to that customer. But we use all of the data, the knowledge of that customer, along with our industry knowledge, to be able to help our customers. So when the Wright brothers were designing, they had many risks to think about, many questions. I wonder if the Copilot could have helped. For example, let's say we've got a part on the plane. We want to reduce the weight of that part for the flight that we're doing. I got to know it's strong enough. Could it hold 1,000 newtons? Could it withstand 1,000 newtons of pressure or force on this part? So to give you an example of what we mean by that, we've got a Copilot, we've got a part here. And I simply ask the question, I say, look, I want to do analytics on this part. The Copilot software looks at the part, does a little bit of analytics, and says, okay, well, based on what we see, you've got 4 holes. I assume those holes are where you're going to fasten or hold the part. And the green is where the load will be applied, that force that we spoke about. The software then runs an analysis on it, and you can see it comes back and it shows me not really that stressful. In fact, you've got a part that's probably too safe, meaning it's too heavy. So what do? We say, well, the software says, do you want to optimize it? And again, all I do is say, yes, optimize the part. So it optimizes, and then it comes back with a different shape. Software design shape that says, you know what, I made it a lot lighter, but it's just as strong. So think about, these are the kind of decisions you can make in the virtual world to move faster with a lot less cost to be able to do these types of things. Another example, in the automotive industry, for example, the Copilot can help you with trade-off decisions. Because we've got this physics-based digital twin, in this case, the designer wants to reduce weight as well on this vehicle, but also not risk the structural integrity of the vehicle. So I asked the question, hey, what are the materials used in this thing? It shows me. And then said, well, you know what, are there alternative materials I could use? And by the way, while you're doing that, could you tell me which ones are more sustainable? How I do that? And again, we're leveraging all of the knowledge of the company and the individuals to be able to bring that, to be able to make these, answer these kind of questions. Another example, I'm a designer, and even if I'm an advanced user, I still can't know everything about every domain, right? So I might just ask simple questions, or I need to have a refresher. I don't know all of the things I need to know. In this case, I'm asking questions about structural and styling. What do I need to know about doing the styling and the structure of this vehicle? And so really what we're doing is bringing all this knowledge together to be able to do that. And while these chatbots are quite interesting, there's a lot more to it that we're bringing to this. For example, when you think about what we're doing with industrial AI, industrial data, and industrial use cases. So for example, we think about AI in kind of three ways. First is analyze. That's going to help you do your task. You're a new employee, you don't know exactly how to do these things. I bring all the knowledge of the company to help you, to run you through. That's analyze. I can optimize, make recommendations about how I should work, the design, trade-off. Maybe I make a trade-off between sustainability and the costs associated with that sustainability effort that I have. And finally is generate. You know what, I describe what I want, let the software build it for me and see what it comes back with. So AI needs the data to be able to do this. And Siemens has a very unique advantage in that our software brings a lot of data to our applications that we do to be able to design, build, whatever. But also, we run many of the factories in the world with our automation capabilities. So all of that data is what we bring together to be able to solve some of these very difficult problems. And again, for AI to be effective, you need a physics-based digital twin. And while I believe we do this better than anybody in the world, you're never really finished bringing those worlds closer together. And what do I mean by this comprehensive digital twin or physics-based digital twin? Think about some of the parts we've discussed. You've got the plane, you've got the headset, just simple examples, things you deal with every day. If your digital twin can only do the mechanical design and can't do anything with electrical, you really don't have a digital twin, do you? And then you've got to think about software. And then you've got to think about the manufacturing engineering, the manufacturing planning of the factory that's going to do it. And then you've got to run the factory. If you take any of those pieces out, you really don't have a digital twin. So you can't make those decisions fast. You can't go in confidence. You can't leverage complexity as a competitive advantage. That's what we bring to our customers. And so when we started building this out, we said, well, what other things could we do? We've been a leader in computer-aided simulation for over a decade. But we recently announced an agreement to expand on this with Altair Engineering. Altair provides capabilities for simulation. It's a $10 billion acquisition, the largest acquisition we've ever done in the history of Siemens. And what they bring to us is, you saw earlier when I took that part and said, make it lighter, make sure I get the strength there. Altair then helps us understand other things that happen in the real world. For example, if I drop my phone, what happens? How can I simulate that? I can simulate a crash of a vehicle and know exactly how the vehicle's going to respond. These are the things that they bring to us. So no other company can provide as much valuable data and insight to their customers through a digital twin as Siemens. It's the reason so many people select us for our software and our solutions that we have today. I'm also excited to talk about a partnership we have with IBM and Accenture. What we're doing here is creating a design and verification environment for software-defined vehicles. More and more products, software is in that. Software-defined vehicle is a term used very much today in the automotive business. And what happens here is, when you develop a product that has software and hardware together, they develop at different paces. The problem is, you need to have a relationship between those two things because they are related. You've got to understand that linkage that's there as you go forward. Consider, for example, the Sony headset. When we're building this thing, we build it for work in an office environment. But now we're thinking, well, what if we go into the factory? Well, the sound in the headset is going to have to be amplified because the factory's noisier. Now I need more power. Is the integrated circuit going to be able to handle that? Right? So you've got to think about those things. You've got to think about electromagnetic interference in the factory. You don't want to discover or to find that problem after you've started fabrication of an integrated circuit onto a wafer. If you find it at that point, it's extremely expensive. We want to make sure we can do that up front as you do the design process. And as more and more companies are developing their own integrated circuits, particularly even in automotive today, they want to do this all up front. We call it shift left. Find the problems early so you can make sure that you're not doing it late in the design and manufacturing process. So what we've done with Accenture, with IBM, is we've defined a framework that allows our customers, a cloud-based solution, to be able to do this. To move quickly, because we find we've built a way to do end-to-end traceability. You make a change in the hardware, software, we can trace the two back together and show exactly how you make those decisions. We're helping our automotive companies get the software right faster and get it out with better quality. Again, it's an enabling factor that's not just a step, but a leap when you think about what we're taking that with our customers. And by the way, you can see some of this at our booth, and see some of the demos at our booths here at CES and what we're doing with this technology. Yes, Peter spoke about startup companies. And I suppose if you think about it, the Wright brothers were the ultimate startup company, right? Not a lot of capital, got to be agile, got to move fairly quickly. And so what we're doing is, to help startup companies, we're introducing a product called Design Center. What we do with Design Center is we take our authoring capabilities. We have a tool called NX for solid modeling, we've got Solid Edge, we've got other types of tools that we use that are cloud-based and so forth, that allow our customers to be able to grow with us, and their data grows with them as we go forward. What do I mean by that? Oftentimes a startup company will select a piece of software, and it works really well as the startup, and then as you start growing and expanding, you need more. And oftentimes what happens then is you've got a major revolution you go through. You've got to migrate data, you've got all kinds of things you have to deal with. We want to make sure that we don't have that with our customers. So companies like Jet0 can start quite small, and as they grow, really what we have is zero interruption with the data. The data can move back and forth through that entire process and make sure that we guarantee that it's an evolution rather than a revolution in the way you deal with the software. It also works for large companies with their supply chains to be able to integrate, because they can be very small companies. You want to make sure the data you produce in those companies is compatible with the larger companies all the way through. Design Center is the way we will solve that problem. By the way, every one of those Sony headsets that we ship to our customer will have these design capabilities included with the headset as we go forward. We're also here today to talk about our Teamcenter digital reality viewer. We bring the digital twin. Again, we bring the digital twin to the process. NVIDIA makes it look photorealistic. I'll show you some examples of how we think about that. If you think about 3D modeling over the years, really you interacted with models that were kind of in basic colors. When you think about how you view the product or view what's going on with the colors in this case. So for example, an automobile. If I want to see it in a photorealistic mode, in the past, you would go to a special room called a cave, and the cave would have these projection screens on the walls, the ceilings, everything else, and you could say, well look, I want to see what the sun looks like hitting a body panel or whatever. But it was a very expensive process because you had to go to this room to do it, and by then, you're limited. Only a few people got to go. We looked at it and we said, why are we not making this available to everyone all the time? That's the work we've done with NVIDIA, to be able to get it and provide the access to this anywhere. And you can see the digital twin, real model, every nut, bolt, screw of the thing is modeled, you know exactly how it's going to go together, and then NVIDIA helps us put the background and makes it look photorealistic as you move forward. So we've talked about this digital twin, the physics behind it, the idea of how we bring it all together, how we leverage AI on top of this. Peter's going to take the next step and show how we bring all these pieces together to really start making decisions a lot faster with our customers. Thank you so much.
So when we add industrial AI to the technologies that Tommy just talked about, like the most comprehensive digital twin, we're actually able to accelerate our path to, yes, the industrial metaverse. And that means that you not only get the experience to get into your factory in the digital world, optimizing it for the real world just 1,000 times faster, you also get the opportunity to ask questions along the way. So let's come back to our factory example, our factory worker. Let's assume you're the plant manager and you are taking over in the morning and you actually want to know what happened there last night and was actually everything properly corrected. And these plant managers now, they are able to get these answers and insights in real time. And the only reason why that is possible is all because of the industrial AI that works in the background of this. And at Siemens, we are the leader in industrial AI. And let me give you the 3 reasons why we think so. For one, Tony spoke about that, we have access to data. And not just any data, but specifically to very relevant data. Every third machine today in the world that is on the shop floor can be connected through Siemens controls. And we manage more design data than anyone else out there in the world with our lifecycle management software. So we have access to design and automation data like no one else. Second, it's not just about the data. Actually, you have to have deep industrial know-how to make that very data useful. Because you have to understand the pain points and the use cases of every single industry that we serve, like the cooling systems in the buildings I referenced earlier. And today, we serve more than 25 industries, from automotive, aerospace, pharma, semiconductor, oil and gas, utilities, you name it. So we bring that deep understanding of what really drives our customers. And then lastly, let me emphasize, AI is not new. We have built industrial AI already for decades. And today, we have more than 1,500 AI experts. And we have a patent portfolio of more than 3,000 AI patents, spanning everything from generative AI to neural networks, to machine learning, to blends of it, again, all coming together. And we see how this technology has the potential to change the world for the better. And that's why we are uniquely equipped to deliver that piece in the industrial world. So today, you heard about Jet Zero, and why Jet Zero chose Siemens as its technology partner, because we are the only company that can deliver the full set of technologies from all the way from engineering to production that they need to transform air travel. Thank you, Tom, for that. And you heard a lot about new technologies that we're going to introduce in this year. Technologies such as the ones that you saw, like the Siemens Industrial Copilot, now also being available on the industrial edge. You saw the Sony head-mounted display for immersive engineering, the NXX Design Copilot, Design Center for small and large, and Team Center Digital Reality Viewer. So all of these technologies enable companies, big and small, to make those leaps that we need. Those leaps to become more competitive, more sustainable, and more resilient. And that is technology that transforms the everyday for everyone. Thank you.